Okay, today we're going to talk about how to extract information from JSON files. And JSON, JSON, stands for JavaScript Object Notation, and it's a specific type of file format that allows data to be serialized so that files can be transferred across, networks and so forth. So for our example, we'll be using an astronomical data set, and specifically we're looking at something called type 1 supernova. So a type 1 supernova happens when a star reaches a critical mass, which is called the Chandrasekhar limit. I hope I said that correctly. Becomes basically unstable, goes supernova, or explodes. And one of the features of these type 1 supernova is they have a known brilliance or luminosity when this happens. And because it's known, this can be used in astronomical research. And these type 1 supernova are called standard candles because of this property of these type 1 supernova. So what we're going to do is actually pull some data from these files. So each of these files represents a type 1 supernova, and these were downloaded from a site called the Open Supernova Catalog at sne.space, and they have a bunch of information that's been collected for these star types. So let's go ahead and take a look at one of these files. And this is essentially what a JSON file looks like, very similar to dictionaries and lists in Python. And it's got the name of the supernova, it's got a bunch of information regarding it, and what we're going to be looking at is the distance of the star. So this field here, and this is measured in megaparsecs, and we're also going to be looking at the recessional velocity. Okay, so we're going to just pull out a couple pieces of information here, a few pieces of information, and then go ahead and build a database, and we'll actually have an exercise at the end to see how you can actually import that into another software package for analysis. So here I've written a simple program in Python, and the first thing we do is import our libraries. Here, so we got our JSON library. This will help us, to internalize these JSON files into Python, and we also are importing the SQLite library. This will help develop our database to hold our information. And then we're going to connect our database. So we're going to call it standard data.sqlite. And then we're also going to create a cursor object. So a cursor here is like a file handle to the database where we can, pass SQL commands to it and, do some kind of operation on the database. So for example, the first thing we'll want to do is if there is already a table in existence, we're going to drop the table. So basically this is useful if you need to rerun your program, if you've made a mistake. It basically starts from scratch each time. So it'll rewrite, create a new database instead of just writing over the old one or whatever. And then we'll actually create a table, okay, inside that database, call it standard data, and it's going to hold three pieces of information: the supernova object name, which will be a text type, the velocity, and the megaparsecs, which are real numbers. And this is basically the structure of our database. So that's really the pieces of information that we want to look at. Now, to read these files, I've actually created another list, a text file, which lists all the file names. And the reason I've made this separate text file is that, if I want to manipulate the data in a different way, maybe eliminate some files or whatever, I can simply eliminate them out of this text file and then rerun my program. So the program will go down this list and then simply know which one of these files to reference. So here we're going to input that file. So we may have a different file name. We can ask the user for it. If not, it automatically defaults to that one there. And it's got a little try except routine here, just to let people know if the file can't be opened for some reason. and we've assigned it to this object fh. So we're going to go through each of these files on there, file names. So that's going to be this for loop, and it's going to read it, and it's also going to add a JSON extension to that file name, so we know that it's going to read one of these files. And I also like to print the file name out just to see what's happening as the program is running. And then we're going to open it as a JSON file. And this part here, this JSON load, basically takes that file and converts it into a Python dictionary / list. So this is where it actually internalizes that JSON file into Python right here. And then once we have that kind of structure, it's just a matter of using index notation to find what we need. So for example, we want to find the supernova object name. Okay, create that, and we go to this JSON file, that's this data that's been put into this data set, this data piece here. Look up file name, or the name. Okay, so let's go ahead and look at our thing here. It's right here is the name, and we're going to pull that piece of information out. The next piece will be the distance in megaparsecs. And again, we have the file name, and we're going to use the index function. We're going to look for this key right there. And that is, let's see here, right here. We're going to pull this value out here. That's the megaparsecs. And then we're also going to look at the velocity here. So we're going to look for the key velocity, pull out the value. And it should be down here. It's right there. So this is the recessional velocity of this star. It's measured by this redshift value up here. So now we've pulled out 3 pieces of information from that JSON file. We of course could pull out as much as we need. And then we're going to insert it into our database, okay, into the field supernova object, velocity MPC. And these values, these are the placeholders for the actual objects that we've just created. So now we've pulled the data out of JSON, and we're adding it into this database, and then we hit the commit here, so it kind of finalizes it into the database. So let's go ahead and try to run this program and see what happens. So we'll go over here to the terminal. This is my file name. This is all located in. And we're just going to hit enter again, and it's actually doing it right now. So it's going through each of these files, pulling out those 3 pieces of information, and writing the database. So we can actually go to the database itself and see if it worked. And there it is. So we have the supernova object name, the velocity, and the distance in megaparsecs. So it's as simple as that. So you can see how simple it is to pull data from JSON files using a fairly small amount of code in Python. That's what makes Python so nice to work with. And now that we have the SQL data file, we can also use it to import it into something else. So for example, I like to use R quite a bit. And let's go to R. And if you're not familiar with R or RStudio, if it's don't even know what those words mean, you can stop the video here. But if you're somewhat familiar with it, R is a statistical programming language. And really what I'm trying to illustrate here is that, a lot of this, data analysis, is kind of used best in conjunction with other programs, because Python and SQL and R are all just tools, and sometimes it's a matter of actually using all of them together to get the best solution possible. So so we've pulled the Python, we've used the Python to get the JSON to create the SQL, and now we're here in R, and I've written a little script file here. So In R, basically we're using libraries to manipulate that SQL file. And we pull a few things together, connect a few things up, and basically what it amounts to is you're selecting those data names from that data and then converting it here into a data frame and so forth. So again, a few lines of code here, and we can go ahead and run this. And there it is. So we've actually taken that SQL data set, converted it into a data frame in R. So again, it's about using different tools to come up with a solution, and it's actually pretty slick there. Okay, well that's it. And again, that is kind of a basic general tutorial on how to do this. And I hope it helps, and we'll talk to you again.